Transmission Control Protocol, TCP IP, and computer networks. We are taking question and answer on it. Explain the range of TCP IP classes. So in TCP IP, it defines 5 classes of IP addresses. They are named as Class A, Class B, Class C, Class D, and Class E. Now each of these class has a range of valid IP addresses. So you see here, this is the start address for Class A, this is the end address for Class A. Similarly, for Class B, Class C, Class D, Class E, and please observe that the first octet, the value of the first octet determine the class. The IP addresses from the first 3 classes A, B, C can be used for host addresses like the computer in your house, laptop in your house. So these are the different classes, and if you see that the last 3 of start address is 000, the last 3 of end addresses are 255, 255, 255. What are private IP addresses? Now there are a range of private address and public address. So the private IP address of a system is the IP address that is used to communicate within the same network. So if you're talking about your network, say in your office, then it will be a IP address called as private IP address. So you have this system, laptop, computer, etc. They are in network and they will use the private address range. So these are the range you see here. Using private IP data, information can be sent or received within the same network. So whenever you see your IP in your system, you will normally see 192.168 point something. Explain, does IP protects data on the network? So IP is Internet Protocol. See, IP by itself does not guarantee delivery data correct. No. Okay. It leaves all the protection to the transport layer protocols, that is the TCP and the UDP. Now the TCP and UDP, Transmission Control Protocol, and this User Datagram Protocol, they have the mechanism that guarantee that the data they deliver to any application is correct. How do they do it? They use checksum. So in UDP and TCP header we have the checksum. So using the IP layer, the correct destination of the packet is identified and delivered. The transport layer protocols, UDP or TCP, will check if the data delivered is correct using the checksum mechanism. Checksum is nothing but adding the header and all the pseudo header content, and then just trying to find out the hash value. And that's, for example, just say 8 is a number. In the destination, if you don't get 8, there is a problem. So if the destination IP is not alive, then the packet is hopped by decreasing the time to leave, that is the TTL field, and when it becomes 0, the packet is lost and undelivered. If the transport layer is UDP, the source doesn't know of the failure of the delivery of the packet. So because that is why the UDP is non-reliable. TCP is reliable. The checksum in TCP is mandatory. In UDP, checksum is optional. Tell the name of the data unit of the transport layer. So this is the TCP IP updated model. The protocol data unit of the transport layer is a segment. Sometimes you call it as a TCP segment. But if you're talking about UDP, it is called as a datagram. Please remember, UDP is for User Datagram Protocol. So datagram for UDP, segment for TCP. TCP are the segments. UDP are the datagrams. So these are the name of the data unit of the transport layer. There are other names also which I highlighted if you just have to look at it. The second question, same thing. Tell the name of the data unit to send by the internet layer. So in the internet layer or the network layer as it is called, The protocol data unit of the internet layer or network layer is a packet, also called as a IP datagram. So if you're calling it as a packet or IP datagram, it's okay. Same thing. What is the difference between TCP and UDP protocols? TCP is transmission control protocol, UDP is user datagram protocol, both are transport layer protocols. The first thing is TCP is a connection oriented protocol. That is like we call telephone network, the call has to be established. So connection oriented means that the communication devices should establish a proper connection before even transmitting the data. And also when it is done, should close the connection after transmitting the data. So the sender and receiver will pass, that is sender will send SYN, that is it wants to synchronize. The receiver will send back, okay, synchronization is okay, I am sending you ACK, the acknowledgement, and then sender will say, oh, I got your this sync and ACK acknowledgement, and the connection is established. UDP is a datagram oriented protocol, so it is not connection oriented, it is connection less. Why? See, this UDP is, there is no overhead for opening a connection, maintaining a connection, or terminating a connection. There is no SYN, ACK or ACK. It gets the data from the application layer and it just sends it. UDP is efficient for broadcast and multicast type of network transmission. It is very efficient. It is just that gets the data, it sends to the port it wants, and it doesn't care about the data whether it is received or not. The second thing is TCP is reliable. How it is reliable? The reliability, because TCP is guaranteeing the delivery of data to the destination router. Reliability means the connection has to be established. So when there is a proper connection, then it can ensure that the data is going and received. The delivery of the data for destination, it is not guaranteed in UDP. In TCP, it provides extensive kind of error checking mechanism. Because there is a flow control, there is every time you get the acknowledgement of data. TCP is full duplex, so every time the receiver or sender sends anything, they will get the acknowledgement, and that ensures the reliability, that ensures the error control. So checking mechanism, you also have a checksum. So checksum is mandatory in TCP. It is not mandatory in it is just optional in UDP header. So UDP has only the basic control mechanism using checksums, but it is optional. So that is what I'm saying. TCP has the header of 20 to 60 bytes and UDP has header of fixed 8 byte. So the TCP has overhead, and these overheads are because they want to control the flow control, they want the acknowledgement, they want the sequence number, they send the different header materials, so that the various, because that is why 20 to 60 byte, they ensure the reliability. Sequencing, as I said, the header of TCP contains sequence number. So sequencing of data is the feature of transmission control protocol. This means that the packet will arrive always in order. If you send 1 2 3 packet, it will always be in 1 2 3 order. Okay, so this mechanism of reliability and proper connection of establishment connection, this means packet will arrive in order. In UDP, there is no sequencing. There is not even a sequence number in the header. So if the order is required, it has to be managed by the application layer. UDP will not know, or it will not consider the sequence number. TCP is comparatively slower than UDP. UDP is faster, simpler, more efficient. Because TCP has, first of all, the overheads are more, the header. And then there is a 3-way handshaking for connection establishment, and there is a 4-way and 3-way the handshaking for termination also. So for every transmission, there has to be 2 more things which are to be there. That is, the TCP is slower. Even if some packet is lost, it will again want to retransmit it in TCP. That is why it is comparatively slower. But UDP doesn't care. It just sends it, and there is no retransmission. So, and the header is also small. Retransmission of lost packet is possible in TCP but not in UDP. As I said, there is a proper sliding window protocol. There are AIMD protocols. The sliding window protocol, it ensures that the packet will not be lost. Every time it has to get an X so that the window is slided to the right side to the next sequence number. See, there is a timer also. If some timeouts happen, then also the packet will be sent. But in UDP, there is no transmission of lost packets in the user datagram protocol. As I said, just mentioned, TCP has minimum of 20 byte header. It cannot be less than that, and maximum of 60 byte. But UDP has a fixed length header, that is 8 byte. All of these discussion you are now knowing because of the header size, because of the sequence number, and all the flow control, error control, etc. TCP is heavyweight, connection establishment, connection termination. UDP is lightweight. For example, you want to do the file transfer, mail. You need to use TCP. For say video streaming, for gaming, you want the speed, not the one or two data is lost or the packet is lost. You don't worry about that. UDP is lightweight. And now you see TCP doesn't support broadcasting. It doesn't support broadcasting. That broadcasting is from one sending to multiple say clients or servers. UDP supports broadcasting. Now the most important, which is normally asked, is what are the services which use TCP. Wherever you want reliability, you cannot afford to lose one or two packets. HTTP, if the web page you open and there is a loss of some data, will you be able to appreciate it? No. HTTP, HTTPS, file transfer protocol. When you are sending file, if 1 byte is missing, the file will not open. For file transfer protocol, the simple mail transfer protocol, you want to send the mail properly, telnet, remote accessing, etc. So this is the TCP, the HTTP, HTTPs, that is S. All these use. UDP for DNS, DHCP. You just send and get. That is, you want the domain names, want to send the web name, and you want the IP. DHCP, you want to get the MAC address through IP. TFTP, SNMP, RIP, VoIP. They are UDP. They use UDP because this is one speed and one is just one request and one fulfillment. How TCP protocol provides reliability? Now this is a very important question always asked. Because the TCP is all about reliability. It is a connection-oriented protocol. This QUIC, you must know about that. This has come from Google. On the background, it used UDP actually. But let us come back to the TCP. TCP is reliable. First of all, it uses the error detection for checksum. It uses the checksum for error detection. In UDP, there is a checksum in header, but it is optional. In TCP, it is mandatory. So error detection. If some data is lost or corrupted packets are there, the TCP will transmit it. There is an acknowledgement policy. Every sequence number of packet has to get an acknowledgement. Otherwise, there will be no sliding of the window. And there will be some timer. If timer gets out, again the packets will be sent. So it uses the features like the byte numbers and the sequence numbers and acknowledgement numbers to ensure the reliability. So reliability is ensured by the sequence number in the header, the acknowledgement number in the header. You see on the right, I have also given there. And in the TCP header, you see there is a sequence number and acknowledgement number. So if packet 1 is sent, see, if the acknowledgement is lost, the packet 1 is supposed that it is not being sent because the acknowledgement is lost. So after say some time, a timer is there. So packet 1 will again be sent until you get the acknowledgement back. Then only the packet 2 will be sent and then you will get the acknowledgement. Assume that acknowledgement 2 is you are not getting, you will again retransmit the packet 2. So let us understand a few more things. TCP must recover data that is lost, damaged, duplicated or delivered out of order by the internet or by the protocol stack. TCP achieves this reliability by assigning a sequence number to each octet it transmits and requiring a positive acknowledgement from receiving TCP. So sequence number is the first byte first number of the first it is actually randomly generated, but that is the first number of that. So you need to get the reply or the acknowledgement that is ensuring reliability. If you're not getting it, TCP will send it again, retransmit it. There is one more thing, which is flow control. Now flow control also helps in reliability by adjusting the rate of data flow between the source and destination for a given session. For this, TCP header includes a 2 byte or a 16-bit field called the window size. So at the time of connection establishment, this window size is broadcasted. It is being said that, oh, this is my window size, you can send this much of data to me. And this same happens on the server side also. So this window size, this sequence number, the acknowledgement, strength is all reliability. Write down the name of services provided by TCP. Now, transmission control protocol provide a lot of services, process-to-process communication, because it is stream oriented, byte stream oriented. There is a full duplex service, multiplexing, and reliability. Main is connection oriented reliability. So all these are different ports and protocols, and these protocols are using the TCP. That is for file transfer protocol, 21 port is used, HTTP 80 is used. If you are using HTTPS, that port will be 443. For SMTP, it will be 25. For mail, of course, you are sending mail every time now and then. So these are the port numbers. These port numbers basically, from 0 to 1023, these are already defined, and beyond that you can use it. So port numbers below 1024 are called well-known ports, and they are reserved for the standard services. As you see, HTTP is 80, HTTPS will be 443, the SMTP will be 25, and others are also given here. And this TCP service, whenever we want to create a connection, it is done through sockets. So the TCP service is obtained by having both sender and receiver create endpoints, which are called the sockets. And the socket will have the socket number consisting of the IP address, and the 16-bit number local to the host called a port number. So there will be an IP address and the port number, and these are the port number which I am talking about. But this port number will be automatically, this socket port number will be automatically generated because it is software managed, and it is generated by the operating system. Explain TCP protocol header format. So TCP header is very important, because everything in the header does something, and that provides the reliability, the error control, and the flow control. So the header, that the other part is payload, called the data. First part is header. Header can be 20 to 60 bytes. The actual data, the stream is here. The minimum size is 20 bytes. It cannot be less than that. The maximum size is 60 bytes. First one is the source port number. Source port number. So sender receiver. So sender will have a port number. So that is the port number, and that port number will be automatically generated, given by the operating system, from 5000 to 6500, like that. Destination port number, of course, you want to go get to connect. You are trying to access HTTP. That will be 80. So that will be a destination port number. Then you have a sequence number, acknowledgement number. So sequence number is the first number and that is also automatically generated, and that is the number which defines the sequence of the bytes which are going. Acknowledgement number is what is coming back. Then we have the checksum for the error detection, window size for the flow control, and then we have the optional data. We have MSS here. We'll talk about that later. Then we have the HLN, that is this is a multiplication. Whatever you have multiplied by 4, that is HLN is a multiplicative factor. Then we have the flags. There are 6 main flags done for various activities, and this can be either 0 or 1. The value can be either 0 or 1. For example, if you want to establish a connection, SYN will be 1, finish will be 1. Write the name of all the TCP flags. So in the TCP header, which is from 20 to 60 byte, this is the range. There are major six flags, and they can have value either 0 or 1. So these are the main 6 different flags. First is urgent. Urgent pointer is valid. That is, it will tell you this part is very urgent of the byte stream. And then the acknowledgement number. Acknowledge number ACK is very important. ACK becomes 1 or 0 depending upon whether it is ACK or not. Then request for push, reset the connection, then synchronize the sequence numbers, SIN. This is when the connection is established. When we terminate the connection, it will be FIN. All value will have either 0 or 1 value. What is the checksum field? What is the role of the TCP checksum field? And both of TCP and UDP checksum are exactly same. Checksum is just adding of few contents and trying to find out a number, and that number will be sent to the sender, and those two numbers will be matched. If these numbers are not matching, we say there is an error. It's simply a hash number which is created by adding the pseudo header TCP UDP header or TCP UDP body. For example, 10 you are sending from the sender, 10 is not received at the receiver, 11 is received. That means there is a problem. There is the error in the packet. So checksum is a simple error detection mechanism in order to determine the integrity of the data transmitted over a network, or whether the data is errorful or not. Communication protocol like TCP IP UDP implement this scheme in order to determine whether the received data is corrupted in between along passing the network. Okay, because of the noise burst and various problems, the data may get corrupted. So in TCP UDP both way, okay, just consider that we have a pseudo IP header, we have a TCP header and TCP body. TCP and header body already, TCP it's 20 to 60, header it is 8 byte. So TCP header and body we add, and there is a pseudo IP header both in UDP and TCP they are generated, and pseudo header will only contain those values which doesn't change, like the IP of the source, IP of the destination, TCP UDP segment length, protocol, and the fixed 8 bits. So this are added. Pseudo header is just created for the time. It has no value. It is just for checksum. So we add them. We create a hash value, and that value is transmitted to the sender, the receiver. Receiver will see match. If it is not matching, there is a problem. That packet or the segment has to be reset again. Retransmission. What is a port? Now port can be answered in two ways. Because in your computer or your laptop or any of the device, you see there are ports. There are serial port. There is USB port, Ethernet port, HDMI port, display port, power port. These are also called port. These are hardware ports. But there are certain software managed ports also that is used in this used by the application layer and other layers to actually establish a connection from one machine to another. So let us talk about the hardware port first. So a port is basically a physical docking point that is used to connect the external devices or peripheral devices to the computer. And we can also say that a port acts as an interface between the computer and the external device. That is, we can connect the hard drives, printer, the scanners, and there are so many using the ports. But now the port I am talking about, there can be different answer. The port is a virtual point where a network connection start and end. The ports are software based and managed by the computer's operating system. It is that TCP IP or other stack in your operating system. Each port is associated with a specific process or service. For example, the 80 service is for HTTP, 443 for HTTPS, 25 is for FTP. SMTP, 25 is for SMTP. So these are the numbers, and these are automatically generated by the operating system. Okay, so this is the difference, and you need to answer both of them in order to get the correct answer for port. UDP also uses certain port. These are also automatically given. Below the 1024, they are automatically defined. They are permanently defined. Above 1024, any number can be given to you. Write the name of the well-known port used by TCP. So transmission control protocol is a reliable protocol, connection oriented and process to process communication. Every TCP segment will be delivered. There is a proper flow control, error control, etc. So in TCP, or we are talking about those protocols which are using TCP. So those protocols we are discussing, they need this reliability. They want this packet to be delivered anyway. There has to be some retransmission if the packet is lost. There will be sequence numbering, there is acknowledgement, this all is happening. Okay, the first one is service. Service uses the port number 7. And this echo port just echoes whatever is sent to it. Both TCP and UDP it uses, but we are talking about TCP which uses. Discard is discard any datagram that is used. So 9 number port it is working. Then we have file transfer protocol FTP. Now this there are two numbers here, 2021. That is whenever you upload, download, these file transport protocol normally works. When you send a file like FileZilla etc. you might have heard. So this TCP problem is if you use UDP, 1 byte mistake, the file will not open. So 21 is for all the control signals or control that is the establishment of when you want to file transfer, there has to be some establishment between two parties. And 20 is the actual file transfer. So there are two ports the FTP uses. Telnet which is the port is used by Telnet to remotely connect to a workstation or a server. So this is Telnet to remote access, remote login, etc. 23 port. 02, 1, 2, 3. These port numbers are well-known ports. Okay, you will not be getting these numbers. The operating system will not generate it for you. These are fixed for well-known ports. Simple Mail Transfer Protocol SMTP 25, and this is used to send email over the internet. If you are using Gmail, Yahoo or Outlook, this Gmail is just a mail agent. So you have to have on the background something to send the mail to the mailbox. That is SMTP. To pick up this mail, that is POP3, Post Office Protocol. Then we have DNS. This www.google.com, this is the name, but there is an IP behind it. So DNS resolve this. So 53 is what DNS uses. Domain names system. Okay. There is a port for DNS request, network routing, zone transfers. Then we have Bootstrap protocol, BootTP 67 it uses. HTTP is very important because internet is everywhere. We are on www. So this is used for browsing web pages on a browser. 80 is the number. HTTP, Hypertext Transfer Protocol. And protocols are just the rules and regulation. For example, HTTPS, the port will be 443. And then I was talking about POP3, Post Office Protocol. This port is used to retrieve complete content from a server mailbox. See, it is not chatting. Mailing is not chatting. So first you have to send it to some mailbox. Then you have to pick it from the mailbox. So these are the well-known ports. Define the term endpoint in TCP. This is not the endpoints of the server and client. That is the sockets. We are not talking about that. See, in any kind of connection for TCP, you need IP and port number. This is how the transport layer TCP works. And especially if you make socket, you need an IP and you need a port. So here the TCP is a transport layer protocol. So we are talking about endpoint, which is not the actual socket points, because this is end-to-end delivery. So let us see this endpoint which you see in this picture. TCP endpoint allows you to easily establish a communication over TCP/IP network connection between the client and the server processes, and these are residing on a different host, different computer. That is very important. Okay. So this TCP endpoint class follows a telephone-like model of networking. That is, previously we used to call on a telephone network dedicated. So client calls servers and servers answers the client. And once a network connection is established between these two, client and server, the two can talk to each other by reading from and writing to the connection. So this is the endpoint which you see here. So TCP endpoints, TCP uses port numbers similar to UDP, but the port space will be disjoint from UDP in TCP endpoints. And then each TCP endpoint will be identified by IP address and port number, which I just told you. So the entire connection will be IP port for server, IP port for client. It will be 4 tuple. Explain the error control mechanism in TCP. So TCP is a reliable protocol. It is end-to-end delivery protocol. It is a transport layer protocol. So end-to-end delivery and reliability can only be achieved when you have proper error control. So when you are sending packet, and if there is a problem, there has to be some way to retransmit. How to know we have to retransmit? There is an error, or there may be other things. So TCP protocol has methods for finding out corrupted segments, missing segments, out of order segments, and duplicated segments. So it has all the possibilities. That is how the error control is important in TCP, because of the reliability it provided. So TCP is in order also. That is, if you are sending packet 1 and 2, it will be delivered in the order 1 and 2 only. It will never be 2 and 1. So error control in TCP is mainly done through 3 simple schemes, which is the checksum, acknowledgement, and retransmission. These are the 3 error control in TCP. Checksum is simply you have TCP header, body, and the pseudo header. So if header is there, there will be a checksum portion. So the header, the pseudo header, and the data is the hash value is generated, and that is sent to the server. For example, you have 18, you are sending say 17. It is not 18. So the problem is there is some error. So what will be there? It will be a retransmission. In TCP, there is an acknowledgement also. The retransmission will be done when there is an error, the checksum has fault, or the acknowledgement is not received. This is the packet once you send from sender to receiver. Now the acknowledgement you don't get. Acknowledgement is all about I got the packet. Now this is the acknowledgement. I am acknowledging it. So the acknowledgement is lost. So packet 1 will be retransmitted. The packet retries sending after some timeout. There will be some timeout or some other mechanism which sends this packet 1 again, retransmission. Okay. So this is where we actually see that this is also an error control, because packet is not coming. The acknowledgement is not coming. So the packet 1 will be resent. Similarly for other packets also. There will be retransmitted until you get the acknowledgement. So checksum, acknowledgement, if you have both the problems or any of the problem, there will be a retransmit. So the error control is all about when the packets are lost or the packets are damaged. So there are certain ways, there are different layers checking different kind of error control. So we have parity checks, CRC, Hamming code, various are there. And there will be a retransmission scheme also. So the automatic repeat request error control is also done. Explain congestion. Congestion, when you feel cold, in your nose, you feel congested. Your throat also, the lungs also feel congested. That is, something is blocking something. So congestion is all about the network say passage is blocked by or overwhelmed by the packets. So a state occurring in the network layer, this is about network layer we're talking about, when the message traffic is so heavy that it slows down the network. For example, this is the way and the car are coming, the truck is coming, ultimately there will be a congestion. So network congestion in data networking, and also it is discussed in queuing theory. This is the reduced quality of service, as congestion is there, so quality will be less. Reduced quality of service that occurs when a network node or a link is carrying more data that it can handle. And typical effects including the queuing delay, packet loss, or the blocking of new connections. There is just assume there is a buffer and it can hold certain data or certain frame or packet, whatever terminology you use. If it is more than that, the packet will be dropped. So this is the concept of congestion. You have packet sent with respect to packet delivered. When the packet sent and packet delivery is equivalent, that is perfect. But sometimes this is not the actual fact. The desirable is what? The number of packet delivered should be somewhat near to packet sent. But when the packet sent and packet delivered has a huge gap, that is delivered are less and packet sent are higher, that means there is a position of congestion, because you see packet sent is higher, congestion is more. What is the difference between stop and wait protocol and sliding window protocol? First of all, they both are for flow control. So you will see them you will talk about them in the different layers, data link layer also, and in the TCP, that is transport layer also. But we are talking about the core of these protocols. Okay. First thing, whenever you send, how much you are sending and how much you are waiting. In TCP, if I go to TCP, the header also, they exchange that, okay, this is my window size, this is my MSS, that is the maximum segment, this is what you can send. So they just broadcast it. But they declare it to the sender and receiver declare to each other. This is the window size. This is how the flow control is achieved. Okay. Now, when we are talking about different layers, these, because in the noiseless channel we use stop and wait. In the noisy channel we use sliding window protocol. In sliding window protocol we have 3 more versions. There are 3: stop and wait and all these ARQ and etc. But we will talk about that. But let us see the difference between these two specifically. Stop and wait protocol, sender sends one frame and wait for acknowledgement from receiver side. So frame we are using because we know that it is data link kind of stuff. In sliding window protocol, sender sends more than one frame to the receiver side, and this is the window. This is not the actual window. This is a logical window, and retransmit the frames which is damaged or suspected to be damaged. Okay, the sender receiver sliding window is going on both the sender and receiver, and these are the number frames are higher. So what you see here is send but not acknowledged, already sent and acknowledged, not yet sent. So this sliding of window will take place when the frames are actually delivered or not delivered. So this is how we achieve the flow control and also the reliability, of course, especially in TCP. So in stop and wait protocols, sender send one frame and just wait endlessly for acknowledgement. If it comes, it's okay. Otherwise, it will wait. The efficiency of stop and wait is worse. Why? Because if the acknowledgement doesn't come back, what will happen? It will wait endlessly. The efficiency of sliding window protocol is better, because if you actually go to the detail of sliding window protocol, you will see that the window will slide also, and there will be some retransmission also going on. So things are better here. The efficiency of sliding window protocol will be, I'll tell you the actual formula also just now. So the sender window size of stop and wait is 1. But what you see here, the window size of sliding window protocol is n. For example, this is 4. Sending the number is 4 here. Then receiver size, stop and wait protocol 1 and 1. So sender will also have 1. The window size, the receiver also will have the size as 1. Okay. When we come to the sliding window protocol, the sender window size of sliding window protocol is n, and the receiver will may be 1 or n. It can be 1 also, it can be n also. It depends on the receiver. In stop and wait protocol, sorting is not necessary. Here, it may be required in sliding, it may not be. The efficiency of stop and wait protocol is 1 by 1 plus 2 into A. A is the ratio of the propagation delay and transmission delay. This comes while making the frame and sending and all this. So this A. And the efficiency of sliding window protocol is n by 1 plus 2 into A. A is the ratio of propagation delay versus transmission delay, and n is the number of window frames. Stop and wait protocol is half duplex. And as I said, noiseless channel it is used, and mainly it is a data link layer protocol, and flow control. The sliding window protocol is full duplex. That is, both the parties are sending at the same time. What is a round trip time? RTT. This length of this is basically a matrix, number. So length of time taken by a data packet to be sent to a destination. It includes what? It includes two times. The time it takes for an acknowledgement of the packet to be received at the original place. You are sending and you are getting the acknowledgement. So the total time is called as the round trip time. That is, if you are going somewhere and coming back, that is the round trip time. So for example, T sub P is the time. One hop and coming back, another hop, 2 TP is the round trip time. So RTT or round trip time is the total time taken to send the first packet to the destination plus the time taken to receive the response packet. This is the RTT. What is the significance of TCP acknowledgements? See, the reliability of TCP lies in acknowledgement. The acknowledgement number is 4 byte in the header of TCP. The sequence number is also 4 byte in TCP header. Checksum is 2 byte. So all checksum, the sequence number and acknowledgement number, they are very important. The window size is for flow control, checksum is for error detection, sequence number and acknowledgement number are for the reliability. So TCP acknowledgements are used to acknowledge packets that are successfully received by the host. When you talk to someone, what do you say? Hey, how are you? If the other person doesn't reply, you will be, in dilemma whether he heard or he doesn't want to reply. This is the same thing. You have to reply, oh, I am okay. How are you? So here the receiver has to reply. He has to give some acknowledgement. Then only things are fine in reliability aspect of TCP. So the flag, which is the, you see here in the header, there is a flag called ACK flag. And this flag is set if the acknowledgement number field contains a valid acknowledgement number. So TCP acknowledgement is all about that something has been acknowledged. So when computer communicate via TCP, the transmission control protocol, received packets are acknowledged by sending back a packet with the ACK bit set. The TCP protocols allow these acknowledgements to be included with data that is sent in the opposite direction, and that is called the piggybacking. So this is piggybacking, but we are talking about the acknowledgements. Acknowledgement is the reliability basis. So I'll just tell you about the sequence number and acknowledgement number. See, because it is related. See, sequence number is whatever TCP segment you have sent, the byte, the data 50 is the first number of the first byte because it is byte stream. First byte. Say 100 bytes you are sending. Now the acknowledgement will come what? The sequence number is 50. The acknowledgement from the receiver will come as 51. Okay? I hope you got the idea. 50 is the first number of byte that is being sent. Acknowledgement will be 51. It is saying, the receiver is saying, okay, I got 50. Now I am waiting for 51. Same thing. When it gets 51, it will give acknowledgement as 52. I got 51. Now please send me 52. So the ACK will always be 1 plus the sequence number. What is retransmission? So retransmission is all about sending it again. Why you will send the packets or the segment or the frame, whichever name you take in whichever layer, why do you transmit? The transmit is, if I say something to you, you didn't get it, you will say, oh, what did you say? I'll tell again. So the TCP transmission, it means resending the packet over the network that have been either lost or damaged. So retransmission is a mechanism used by protocol like Transmission Control Protocol TCP to provide the reliable communication. So what is the reliability? That if you lose something, I will cope up with that. Means I'll just send it. So the reliable communication means that the protocol guarantees that packet's delivery, even if the packet has been lost or damaged, it will be resent. The networks are unreliable and do not guarantee the delay of the retransmission of the lost or damaged packet. I'm talking about the actual networks. So some protocol like TCP have to provide the reliability. So the network which uses a combination of acknowledgement and retransmission of damaged or lost packets offer reliability. So acknowledgement plus retransmission is the key for reliability. So the TCP retransmission, it is just meaning that resending the packet over the network that have been either lost or damaged. So retransmission is just a mechanism used by protocol like TCP to provide reliability. This is a question: if TCP round trip time RTT is currently 30 millisecond and the following acknowledgement comes in after 26, 30 to 24 seconds, we'll take the first one. What is the new RTT estimate? There is a value alpha. This alpha is 0.9 here. So just this is the expression we are going to use. So this is the estimated RTT, which is estimated RTT into 1 minus alpha plus sample RTT new into alpha. So this estimated RTT will take as 30. The sample RTT we are going to take as 26, put the value 0.9 and 29.6. This is a new round trip time RTT. What are the features of TCP? Now you can add transmission control protocol with the transport layer work also, because the basic transport layer protocol is TCP and UDP. So TCP is all about end-to-end delivery, okay, process to process delivery. So let me just give you an idea about the upper layer. The application layer, for example, you are using Facebook or you are sending some data to someone. Now you are just sending the data. So the bytes are coming. So application layer is sending the data. Now there is a transport layer below it. So host A and host B has to provide end-to-end communication. So the application layer will send all the data to the below layer, which is the transport layer. Now I am talking about the TCP and UDP. This is SCTP also, which is a finer type of TCP. I'll talk about that. But here TCP will take this data and convert it into TCP segments. And with these TCP segments are then sent to the network layer. So for example, HTTP will use TCP, and if your process is say some other DNS, it will use UDP. So now here the TCP is the sender and receiver. They start a conversation with a three handshaking in TCP. So they will first make a connection. That is why we are calling it as a connection oriented. So an application requests a connection to the destination using a handshake and then uses the connection to transfer data. This is the first feature of TCP. Then stream data transfer. As I just suggested, TCP is byte oriented. It is the duty of TCP to pack this byte stream into packets. Actually, it is called as TCP segments, which are passed to the network, or you can call as IP layer, for transmission to the destination device. So TCP takes all the bits coming from the, or bytes coming from the application layer and then convert it into TCP segment, adds the header and then transfer it to network layer. So it will make a TCP segment, and this is, see this is totally a byte stream. So this is the header of TCP. It can be 20 to 60 bytes. And it goes to network layer then. The important part of TCP is reliability. Reliability is achieved through acknowledgement and the retransmission. So if TCP segment has to get an acknowledgement. If you are not getting an acknowledgement, there will be retransmission. If some error is there, retransmission. It recovers data from the network layer if the data is damaged, duplicated or corrupted. Point to point, end to end, process to process. TCP connection provides end-to-end delivery, that is from one point to another. That is the port from, see in the header there are port numbers, source port number, destination port number. Source port number will be given by the operating system to you. And then on the destination port number, say for example you are using web or you are on internet accessing web page, the destination port number will be 80. So you are talking about point to point, end to end delivery, that is process to process communication is taking place here. Then we have the error and flow control. See, for flow control, there are various mechanisms. It uses the sliding window protocol and other protocols. The error for this, it uses the checksum. TCP uses checksum. In TCP, the checksum is mandatory. In UDP, it is not. So the sliding window protocol normally is used by TCP. So this is the sequence number, acknowledgement number. See, sequence number is 8000, acknowledgement is 8001. So acknowledgement is acknowledging that this sequence number, that is the first number of the byte, has been sent. Okay, thank you. But if this acknowledgement is not sent, there is a problem, retransmission. Error is checked by checksum. Checksum is header plus the data, that is the payload, plus a pseudo header. We combine them, create a hash number and send it to the receiver. The receiver will match these numbers. If the numbers are not good, it will say please retransmit. So flow control is all about sliding window protocol type of protocols like the window size. So there is a broadcast, there is a arrangement that this is my window size, this is my window size, this is my MSS, this is the segment. Don't send more than this one. Full duplex. TCP provides full duplex, means the sender is also sending it at the same time the receiver is sending. Explain the process of three-way handshaking protocol. So in TCP connection or in TCP protocol, the first thing which happens is this three-way handshaking protocol. It takes place. That is, this is your host A. Now this host A wants to get connected to host B. So what will happen? The first thing, it is for the data transfer. So host A will tell host B, host A, I want to talk to you. Now what host B will do? It will send something like agreed, I also want to talk to you. Now the host A will again get back to host B and he says, okay, agreed. Please remember, in TCP connection, every kind of communication will be acknowledged, whether it be establishing a connection, whether it is finishing the connection, or you are transferring the data. That means every communication, a single bit of communication will always be acknowledged, and that is the reliability what TCP provides. Transmission control protocol, this is a transport layer protocol. So in order to understand this, what is happening, you need to understand the header also. The first thing is happening is what? The first step. Now client wants to establish a connection with the server. So it will send a segment with SYN, that is synchronize. This is SYN is for synchronize, and it is sending a sequence number also. So you can call it as a synchronized sequence number, which informs or which tells the server that I want to start communication, and with this sequence number, it starts segments. That is, it will send SYN. Okay, I want to do the communication. Now SCQ equals 1 is what? That is the first byte of the data it want to send. Now host B will do what? It will synchronize and ACK. It will send the SYN and ACK along with acknowledgement. Acknowledgement will always be 1 plus sequence number. That is, the sequence number is 1. What is the sequence number? This is the first byte number of the data which the host A wants to send to host B. Let us assume it is 1. It will be a random number. Let us assume it is 1. Now when the host B will react, it will send ACK as 2. That means, okay, I got your point. You are going to send 1. I got 1. Now this is ACK is 2. Always ACK will be sequence number plus 1. ACK will be from the other side. Now it will also declare, okay, you have told that your first address of the first byte is 1. The data I am going to send you, the address of the first byte will be 50. So first 1 is sequence number of the host A, and the host B data, first data byte, the address will be 50. So now both have exchanged some communication, and they have also declared also. They are talking also, starting to do some certain communication and declared the first byte of data also. Now the third thing will be, host A will again acknowledge with 51. Okay, let's start. Now 51. As I said, every communication will be having an acknowledgement. So now the third one, send ACK, is having 51. And I told you, ACK will always be the previous sequence number plus 1. So it will be 51. And this is how the three-way handshaking protocol works. So the steps 1 and 2 establish the connection parameter, that is the sequence number from one direction, and it is acknowledged. Step 2 and 3 establish a connection parameter sequence number for the other direction, and now it is acknowledged. So with these two type of three-way communication, this is a full duplex communication. That is with these three messages, full duplex communication is established. What is SCTP protocol? Why are we discussing SCTP? Because transmission control protocol, this is the most widely used transport protocol. So SCTP, it stands for Stream Control Transmission Protocol. Please listen again. Stream Control Transmission Protocol. So this is a connection oriented protocol on the computer networks that provides a full duplex association. That is, transmitting multiple streams of data between 2 points at the same time. We are calling it as next generation TCP or TCP NG. So SCTP makes it easier to support the telephonic conversation on the internet. So a telephonic conversation, it requires the transmission of voice along with the data at the same time on both ends. So the SCTP protocol makes it easier to establish a reliable connection. The SCTP is also intended to make it easier to establish the connections over the wireless networks and managing the transmission of multimedia data. So SCTP is a standard protocol. It is defined in RFC 2960 and it is developed by IETF. So this is IETF is Internet Engineering Task Force. Differentiate between leaky bucket and token bucket algorithm. So let me tell you about the leaky bucket. Now see, we'll talk about this data transfer just now. Just understand the scenario. There is a bucket and there is water coming inside. Now it depends on the knob, how much you open it, water will come. The water may come at higher speed or it may come at lower speed. So it may come at 2 Mbps or 12 Mbps if we talk about data. The data rate can be 2 Mbps, 12 Mbps. Now you see, as compared to 2 Mbps, 12 Mbps is a bursty data. The speed or the data content has increased. But a leaky bucket has a simple leak. So whatever you put inside, 2 Mbps, 12 Mbps, only 3 Mbps will come out. That is, the data rate or the data flow out of this leaky bucket will always remain constant as 3 Mbps. I hope you got the idea. So it is there to handle the bursty data. Now, here we have 5 packets. In this bucket, there are 3 tokens. The packet has to grab a token and then only it can come out. So first, second, third, they are getting the token which is there inside the bucket. 1, 2, 3, they are grabbing the token and they are coming out. But the token are finished now. So these 2 remaining packets will remain as it is. They will not be able to enter the channel. So the first one, leaky bucket, when the host has to send a packet, the packet will be first thrown into a bucket. You can call it as a buffer. Okay. In the token bucket, you have to, or the packet has to hold the tokens generated at regular interval of time. In the leaky bucket, the rate of water coming out or data coming out will remain constant. If you put 12 Mbps, 20 Mbps, 50 Mbps, 1 Mbps, 3 Mbps, doesn't matter. It will always be 3 Mbps. In token bucket, the bucket has a maximum capacity. That is, capacity is what? Number of tokens. Okay. Now, next one, the next difference between the leaky bucket is, as I said, the flow rate is constant. Here, the flow rate is not constant. It depends upon how much token are being generated. And that will be only generated with respect to the network situation. In the leaky bucket, the bursty traffic or the data which is coming at some time at a higher rate, immensely high rate. So bursty traffic is converted into uniform traffic by the leaky buckets. In the token bucket, there is a ready packet. A token is removed from the bucket and then the packet is sent. So whichever is the latest will hold the token and will come out. So what happens in practice, the bucket is just a queue. So it's a finite queue output at a finite rate. So first in, first out. Oh, last in, first out. So now here, if there is no token in the bucket, nothing will happen until the tokens are generated. What are the TCP connections phases? So in TCP connections, there are three phases. The first one is called the connection establishment. This is also called as three-way handshake. This second part is once the connection is established, data transfer will take place. And in this data transfer, the sliding window protocol and other protocols work. So the window size is declared and they are used so that there is a proper flow control. Okay, and both of the sender and receiver, they will declare and they know each other's size. This is how the flow control happens here, and the data is also transferring. Finally, the connection is terminated. So data transfer is the middle part, but the first one is here the client will ask or it will request for a connection. It will send certain sequence number. Say sequence number is 8000. This is automatically generated. Server will respond. It will respond. Always the acknowledgement will come for any kind of communication. ACK will come. So the acknowledgement will be sequence number plus 1. The sequence number is nothing but the address of the first byte of the data stream which is going to come. So 8000 is the first byte of the data stream client want to send. The server responds with okay, I got 8000. Now you start sending from 8001. That is the ACK. Now it is also, server is also sending. Now you told me that okay, your data will start with address 8000. Now my data will start with address 15000. Okay. Now sequence number is just the address of the first byte of the data to be sent. Next time, the client will send an ACK. Now you see A and S are the flags. S flags in the last three-way and communication, last one, there is no S. So it will send ACK. Okay, I got it. 15001. You start sending from 15001. So the connection is established. Now here the ending of connection. So here we have control flags in the header. So the control flag FIN is also a flag. This will become 1 now. That is, the client want to finish the connection. Once this FIN is sent, the receiver will not be, it is now passive close. It will not entertain anything from the initiator now. It will just send an ACK. As I said, for every communication, there has to be an ACK. So now after ACK, the receiver will also send the finish. That is, finish flag is 1, and finally an ACK, and the communication will be closed. This ACK and fin in between can also be combined in third way together, and you can call it as a three-way handshake on the other side. Write the features of TCP sliding window. Now this TCP sliding window, the sender and receiver, whenever they start the communication, they also send the window size. Actually, the window size is always in the header. So for let's say example, the window size is 4 here. So this is happening because of the flow control. Please remember, this window size is logical. It is not real. This is how it is implemented. There is MSS also sent, that is the maximum segment size. This is for the network. And this 4 is for actual process. So what happens here is the communication start and the data is sent. The data is sent and there will be acknowledgement. Until all the acknowledgements are received, the window will not proceed. The window will proceed with the retransmission if any of the packet acknowledgement is not received or it is lost. So this is how the reliability, first of all, because every acknowledgement has to be received, and second thing, there is only 4 packets which are being sent. Every time 4 window step is going on. So there is a flow control also, there is a reliability also. So features of TCP is it uses variable size windows to provide flow control as well as reliable transfer. The TCP connections, this mainly is reliable and it is also providing the flow control. TCP is a transport layer protocol. TCP connections are full duplex. That is both the side the data is also going, ACK is also coming. So two transfers proceed simultaneously over each connection, one in each direction. So it support machines of various speed and size communicate through a network and also routers of various speeds. What is the maximum size of the TCP header? So what is the minimum size of TCP header? Now let me tell you about UDP first. UDP has a fixed header size of 8 bytes. TCP, the minimum is 20, the maximum is 60. So the minimum size of TCP header can only be 20 as UDP has 8 byte fixed. So 20 bytes minimum, 60 maximum. Do port addresses need to be unique? Why or why not? Why are port addresses shorter than IP addresses? Let us rephrase the question as what is IP and what is port number? What is the difference between them? So first of all, let us understand here. IP address is to know the machine. This is a 32-bit address. Dot, decimal dotted. So the one octet, one part can go up to 8. So see, this is 8-bit. So 2 to the power 8 minus 1 is the maximum value. It can be 2 to the power 8 is 256, 256 minus 1 is 255. So one octet, there are 4 octets here. So 4 octet, 255, 255, 255, 255. So this is the IP address. Now this has to identify the machine, that is a host on an internet, on a communication network. Okay. Now this IP address, that is the internet protocol address. Now port is a software generated value. Now this port is for a process. A process, it is, for example, port is 80. Port is 80, that means you are talking to a web server. 80 is for HTTP. So whenever you are making a socket connection, there are tuple, means two values you have to send or know. The port number and the IP address. See, port number is not hardware number. There is no proper port. It is software generated. Now see here, the host A wants to communicate with the server. For example, you are using a web page. You have opened your Chrome and you are accessing your web page. Now this web page will be coming from where? It will be on certain server. The server is uniquely known on the network with the IP address. This IP address is 2000.0.0.1 and that is called the IP address. Now which service it has to use? The web page will communicate in server at port number 80 because port number 80 is reserved for HTTP, for web services. For example, host A is transferring the file. It has to transfer a file or download a file. So it will not ask for port 80. It will ask for the port number 20 and 21 and that is for FTP services. So port 20 is for data and 21 is for signal, for FTP. Control. Okay. So this is the port number. For telnet, because if A wants to remote log into this server, so the IP address in all these three cases will remain same, but the port will be now 23. This is specific for the telnet services. So the port addressing is done by the transport layer, which is the fourth layer of ISO OSI model. If you see, the port addresses are short. Why they are short? Because they have to perform end-to-end delivery of the message, and the protocols are less in number. That is, the 0 to 0, this is software generator, okay? So 0 to certain value. Actually, the port number is 2 byte. So 2 byte means 2 to the power 16 is the maximum value. Actually, it starts from 0. So the maximum value will be 0 to 2 to the power 16 minus 1. 2 to the power 16 is 65536. So the port number maximum will be 0 till 65535. So these are lower number than the IP address. IP address is 32 byte. So it can go up to 0 to 2 to the power 32 minus 1. So I am talking about IP address. IP is this port number. Port number is from 0 to 1023. It is already fixed. That is, for port number 80 is fixed for HTTP. So whenever you will get a port in your operating system for any service, you will get above 45,000 till 65,000, because this 0 to 1023 is already fixed for various services. For example, HTTPS port number is 443. So port addresses are short, as you just saw, because these services are less, the protocol are less. But the IP addresses, how many machines are there? Now in your home, you will have in your mobile, your computer, your tablet, all will have some IP. So that is why the IP addresses are huge, because the systems are huge, but the services are limited. Even 10 to 1023, this is enough for it. Right now it is enough. Still we have after 1024, that has to be taken from 1024 till 45,000. You have to take it from IANA. That is, you have to register it. So IP address referred to the computer device connected to the network, and the port address referred to a particular protocol to communicate with the server as per client request. For this example, I just told you about the web page or web services you want to access. You can only ask for port 80. What are registered port and dynamic port? So we have well-known ports, registered ports, and dynamic ports. Now, from where the number has come, what are the ranges? So these are 2 bytes. Actually, the port numbers are 2 byte, that is 16 bit. So 2 to the power 16, this is the total range. So from 0 to 2 to the power 16 minus 1, because we are starting from 0, not 1. So it will be from this 2 to the power 16 is 65536, and this will be 65535. Now from 0 to 65535, this is the whole range. What are the well-known ports? Well-known ports are from 0 to 1023. These are well-known ports. For example, if I say 80 port number 80, that is for HTTP, web pages, web services. This 80 is for HTTP. Similarly, I say 20 or 21 number, this is for FTP, file transfer protocol. 21 is for control, 20 is for data transfer. 443 is for HTTPS, hypertext transfer protocol secured. Now from 1024 till 49151, the ports ranging from 1024 to 4915191, these are not assigned and they are controlled by an authority. Previously it was called as IANA. I tell you the new name. They can only be registered with IANA. Why? Because there are many companies, they want to use the ports, because ports are all about processes. So they can just use their ports. So you have to go to register. For example, 1096 you start using. No, you have to go ask with IANA, then they will give you. Dynamic port, you don't need any registration. This port ranging from 49152 to 65535, from here to here, these are neither controlled nor registered. Let me tell you again, 49152 till 65535. They can be used in any process. Any process. So I was telling you the registered port numbers are the port numbers that companies and other users register with ICANN, that is Internet Corporation for Assigned Names and Numbers, for use by the applications that communicates using this Internet's TCP, Transmission Control Protocol, and User Datagram Protocol, because these ports are operating system generated. So whenever some process has to talk, they need to talk on this port only. So end-to-end communication, end-to-end delivery is the transport layer work where this TCP UDP is actually lying. Now coming to the dynamic port, this is also called as a private port, and this is one that is assigned to a process or a service at the time the port is needed. Usually whenever your system will go up, that is operating system will start with the process or service, whenever it starts, it needs a port, and that port number is given here. What is the importance of TTL field? Now here you see we have a TTL field. This TTL is for time to live, and the packet has a time to live. Why do we require this? The TTL is the lifespan or the lifetime of the data that is being sent. Time to live, because after that time, what will happen? Once after that specified time is over or elapsed, the data will be discarded, or it can also be stated as the number of hops that packet is said to exist in the network, after which the packet is discarded. There is number of hops or the time after which this packet will no longer be in the network. Why? Because there are so many networks, so many packets which are being roaming around. They are dropped by the routers and different electronic devices. So the purpose of TTL is to avoid situation in which an undelivered datagram keeps circulating in the network. That is those which we call them immortals. So the purpose of TTL, this is time to live, is to avoid a situation in which the undelivered datagrams keep circulating on an internet system that will swamp the network. So TTL, or time to live, of an IP packet I am talking about, represent the number of IP routers that the packet can go through, or number of hops before being discarded eventually. What are open loop congestion control and closed loop congestion control techniques? See, the fire, if it happens, you have to extinguish it. You can do one more thing. You can do something so that fire cannot happen. So open loop congestion control policies are applied to prevent congestion before it happens. The congestion control can be done either by source or the destination. This is the first open loop congestion. Now, what is the closed loop congestion? This closed loop congestion control technique is used to treat or elevate congestion after it happens. These are two kind of congestion control techniques. Congestion control, the open loop, the different policies are retransmission policy, window policy, acknowledgement policy, discarding policy, and admission policy. The closed loop, we have back pressure, choke packet, implicit signaling, and explicit signaling. Which fields of the IPv4 header change from router to router? So there are certain fields which will remain from end to end, but they are from router to router. That is, you can say hop to hop. The total length field and the header checksum of IPv4 header, this will change from router to router. Total length and header checksum. So you remember in TCP what we make as checksum? Only those fields are made as pseudo header which doesn't change. Explain the reason for the elimination of checksum in the IPv6 header. IPv6 header. So before we go ahead, let me tell you something about IPv4 and IPv6. IPv4 was deployed in 1981, while the IPv6 deployed in 1998. IPv4 is 32-bit IP address. 32 is like this, 8888, they are separated by a dot. These are numeric dot decimal notation. And each has 8-bit maximum. So 4, 8 4 is 32. Here we have one IPv6 128-bit. So you have 128, that is 32, like this. So this 32-bit, let me tell you the numbers, how many machines it can address. 2 to the power 32 minus 1. So this will be 4.3 billion address. 128 it's a huge number. 2 to the power 128 minus 1, that is 7.9 into 10 to the power 28 addresses. You can imagine. See, IPv4 DHCP or manual configuration, IPv6 supports the auto configuration. Let's come back to our question. IPv4, IPv6, you know that TCP has to have checksum. UDP optional. So the checksum is eliminated in IPv6 because it is already provided by the upper layer protocols that like this TCP. So TCP and UDP. So transport layer protocol. So UDP checksum, which was optional in IPv4, is being made mandatory IPv6. So in TCP, you need to have the checksum and you have to deal with it. And this UDP was optional. Even if you don't want to do checksum, it doesn't matter. But in IPv6, this UDP checksum is mandatory. Therefore, the checksum at layer 3 is redundant. That is, at network layer, there is no point in having checksum. So the header checksum field is unnecessary in IPv6 and suppresses the recomputation process each time a packet passes through a router. So hop to hop, why to check every time? Because checksum is already there in the IPv4, the TCP. Now it is in the UDP also IPv6. Write down the name of the 3 strategies used to handle the transmission from IPv4 to IPv6. See, IPv4 32-bit, IPv6 128-bit. Now, what happens is, or what has been thought, that every home has 4 or 5 members. Everyone has a mobile, laptop and tablet. So there are so many mobiles, so many laptops, it means so many devices actually. So how to deal with these numbers of ever increasing devices? You need to have large number of IP addresses. For that, this IPv6 came. So we have to transfer, or you can say transit, from IPv4 to IPv6, which is not a very easy task because of the huge number of systems on the internet. The transition from IPv4 to IPv6, which is not an overnight process. It will take a long time. So this is what transition means. So it takes a considerable amount of time before every system in the internet can move from IPv4 to IPv6. And the transition must be very smooth to prevent any kind of problem between the transition from IPv4 to IPv6 systems. So the question is asking, what are the strategies for this? So we have dual stack, tunneling and header translation. So let me tell you about one by one. Dual stacking is running both IPv4 and IPv6 on the same device. Both are running. Tunneling means transporting the IPv6 traffic through an IPv4 network transparently. You have an IPv4 network and you are just transporting this IPv6. This is basically tunneling. So transparently. And translation is converting IPv4 traffic to IPv4 traffic for transport and vice versa. What is tunneling? Now this one on the left this is an Ethernet network. The right one is also an Ethernet network. Inside we have, in between it has to pass through a WAN. Now WAN packet is different. IP packet is different from Ethernet frame. So what to do? Now what can happen is the WAN packet can take this IP packet and put it inside as a payload. So IP packet is inside the payload field of a WAN packet, wide area network packet. Okay. So the technique of internet networking called tunneling is used when the source and destination networks are of the same type they are connected through a network for a different type. We have a WAN in between, which is connecting to Ethernet. So for that, just take the packet coming from the Ethernet, put it as a payload and transfer it onto the other side, and the other side will take care. So tunneling is a way to move packet from one network to another, and tunneling works via encapsulation. That is wrapping a packet inside another packet. What you see here also. In WAN packet, you are actually wrapping or encapsulating the IP packet, and then you are transferring. So this is mostly this is a very popular thing in networking. What is fragmentation? Fragmentation means big piece, you are dividing it into smaller pieces or fragments. I'll tell you about the diagram, but let me tell you that fragmentation is an important function of the network layer. So it is a network layer process. It is a technique in which the gateways or the systems break up or divide large packets into smaller ones, and these are called fragments. Bigger fragment into smaller fragment. This is called fragmentation, and these small are called fragments. Each fragment is then sent as a separate internal packet. Each fragment has its own header and own trailer. Header and trailer each fragment will have. Now, sometimes a fragmented datagram also gets fragmented when it encounters or it comes into a network that handles smaller fragments. So the datagram can be fragmented several times before it reaches actually to the final destination. The reverse process of fragmentation is somewhat difficult. That is called the reassembly. The reassembly of fragments is usually done by the destination host, because each fragment has become an independent datagram now. So this is the whole process of fragmentation, and it is done heavily on the network by the network layer. Now let me show you here. See, we have a packet coming. This is a gateway 1. Now gateway has divided the packet into fragment. Now it has crossed to gateway. Now it has again reassembly is done. Now this is coming to G3. So here you see G1 has divided it into 6 packets, 6 fragments. G3 has divided it into 3 fragments. So it depends on the network also. So let me tell you again that fragmentation is done by which layer? Layer 3, network layer. When the maximum size of the datagram is greater than the maximum size of the data that can be held in a frame. What is that? That is called the MTU, maximum transmission unit. MTU. So the network layer divides the datagram received from the transport layer into fragment so that data flow is not disrupted, and the network can handle it, because if you have a bigger size, they simply drop it. What are the 7 layers of the OSI model? ISO OSI model. So there are 7 layers. There is one more counterpart which is widely used, and that is called TCP IP protocol stack or TCP IP model. We have 5 actually layers of TCP IP. Earlier it was 4. So these 7 layers of these layer are application, presentation, session, transport, network, data link, and physical. You can remember it by APST NDP. APST NDP. So the first one is the application layer. This is the, please remember, these layers are not actual layers. These are conceptual. This is not actual layers. The only thing is that the protocols, the services, the rules, everyone, you are staying somewhere else, I am staying somewhere else across the globe. We need to follow these rules. And the network connections, network devices, all the network topologies, they have to follow these rules. Then only there will be proper communication. So application is the end user layer. That is, you are interacting with your system in order to use the networking services. So for that you need certain protocols. That is, whatever service you use on the background, certain protocols are there that are going to fulfill it. That is, services based on this protocol. For example, you are accessing web page. You are using HTTP. Then FileZilla, you are using FTP. Now you are using DNS. That is, you are typing say www.google.com. Nobody knows google.com. Only DNS, that is the IP address of google.com, is known to the computer, because computer doesn't understand the names. It just understands the number. That is the binary number, that is the bits. So DNS will convert this google.com into the actual IP address, and this is what is being given to the layers below it. Then we have, so you have started the work. Now bits and bytes are being sent to the presentation layer. Now this is a syntax layer. You might have heard about the SSL, SSH, IMATP, FTP. MPEG and JPEG are the most widely used video and the picture formats. So how the data will look, this is the presentation layer. And whenever some communication happens, there is a session. That is, after some time some session will end. So synchronization and sending to port, that is the APIs, the sockets and the WinSock, all is done here in the session part of this 7-layer protocol stack. Then we have the transport. Transport layer is very important, because here the end-to-end communication take place. That is, you have opened a web page. Now this is a process. Now this web page would be coming from some server. Okay, that is coming from server. So the server port will be 80. So you will give at your system you will give IP and the port. That is TCP and UDP will take over. TCP is transmission control protocol. It is a reliable connection oriented protocol. UDP is non-reliable connection-less protocol. That is, if you are sending email, if you are sending a file, you must use TCP. If you are doing the audio video work, then you can use the UDP. So from computer to computer, host to host, it is okay. That is work of the network layer. But from the host, that is the computer, to actual service, that is the work of the transport layer. Now the network layer. Now the TCP segment and the user datagram protocol, the datagrams will come to network, and now network will convert them into packets, and using the internet protocol, and we have ICMPs and IPsec, IGMP, it will send it to the network. That is, actual fragmentation and all those things will happen here. So network is the actual, all the routers or etc. work here, and the packets will be, we always call it as IP datagram. That is the packet. Now coming to the data link layer. Here these packets will be converted into frames. Now this Ethernet, PPP, switch, bridge, all these devices, they work here in the data link layer. So this is the penultimate layer, because the physical layer is the actual layer where the bits will be transferred. So coaxial cable, fiber, wireless, hubs, repeaters, all are there in the physical. Actual bit transfer is taking place at the physical layer. So when you start working, you are interacting with the application layer, or you are working on application layer, and then the series of working will be done by these layers, and it will be sent, and this will be received by physical layer of another system, and it comes to application layer. How many layers are there in TCP IP? So transmission control protocol, internet protocol, has 5 layers. Okay. Previously, or the counterpart is ISO OSI, International Organization of Standardization and Open System Interconnection. This is the model of 7 layers. Now, the makers of TCP IP, they combined this APS, application, presentation and session, and they made it into one. And other layer are still the same. The main idea of TCP IP protocol stack is, on whole internet, this TCP was used widely, transmission control protocol, and network layer IP was used a lot. That is why the name of the protocol stack itself became the TCP IP, because of these two very important and very popular protocols. These are actually the protocols, but the whole stack is named like this. Okay, now the first is the application layer. So we'll start with the application layer. Just understand you are interacting with the application layer, because application is all about the user working and trying to use the network service from where it will use. See, you and me are in, I am in India, you are in Nairobi. So we have to have certain network protocols, some certain rules, regulation that we need to follow so that we can talk on network. So the header, the trailer, the protocol, the fragmentation, the routers, hubs, all these follow certain protocols. That is how we are communicating. A whole world is communicating to each other. That is why we have this TCP IP protocol stack. This is not real. This is actually logical. This is logical. Sometimes you may skip, your device may skip some of the layer if it doesn't require it, right? But certain layer, like the application layer, the way you interact, the physical layer, the bits are going, this needs to be there. But some of the layers, they may be skipped. But at the point of implementation, I'm just saying that these are the 5 important layers. You can remember it by AT&DP. So coming to the application layer, here you are sitting in front of your system or computing device. This application layer is where the application and software need network communication to function. For example, your web browser, and you are requiring a service from, say, web service or web server. So here you are trying to access the network services, or you are trying to use the network options. So from where you will start? You start with application layer. So it will be a software, it will be a network utility. It may be something related to network. So that network layer service providing will only start with the application layer, because you are interacting, and the point you are interacting is called the application layer. We have various protocol, SMTP, FTP, Telnet, etc. Coming to transport layer, very important layer. Now this is responsible for process-to-process communication and end-to-end delivery. So the user has asked for certain network service. Now he has started some work. That kind of content will be coming to the transport. So application layer interaction will give rise to the actual data, and that data will flow to the transport layer. So these are the port addresses I am just talking about, because IP address is the specific address of a computer on the internet or on the intranet. But port is very important, because you are talking to this, you are not sending it to the system, you are actually talking to this process. So a web page will be talking to the process, the web server process on the other system. That is called process to process communication. So it is responsible to establish a reliable connection if you are using TCP, and fast connection, unreliable connection, which is UDP, with the application layer by assigning a port number of source and destination. So TCP, as I said, it is a reliable connection, and TCP, the content will be made, that is the bit stream coming will be made as TCP segment. The UDP, again it will add 8 byte of fixed header, and there will be a payload. So if you are using video call or voice call, UDP will be used, or you should use UDP. If you are actually sending the email or say file transfer, you need to use the TCP. There are other protocols also in the transport layer, but these are the most important one. That is why we are discussing. So please understand, this is end-to-end delivery, and then we have this process-to-process communication. Now TCP segment, UDP segment, the datagram we have prepared. Now it is coming to the network layer, and this is one of the most important part of the protocol stack. So the transport layer was having segments, TCP segment. Network layer will have IP packets. So it is responsible for creating data packets and adding a logical address, that is IP address 162.192.6.1. This is the IP address by which a host or a computer or computing device will be known to all the other systems on this globe. Okay. First of all, the assignment of logical address and the routing traffic. So routing from source to destination, that is host to host delivery, is done by network layer, computer to computer delivery, and here most of the work is done by this IP, that is the basic internet protocol. Then we have ICMP, IGMP, ARP, RARP, all is there. So it is basically the router, which router it has to go, that is hop to hop delivery, and where it will go. Then the packets are being found. Now it goes to the data link layer. Now this data link layer deals with creating the frames. So it will also add the IP packet. Mostly the fragmentation part is done at this layer, the network layer, and now these are converted into frames. And the data link layer will add some header and also some trailer that moves across the network. So it performs physical addressing of data by adding MAC address to it. Now see, very important, network layer was assigning a logical address which was the IP number, but data link layer is adding MAC address. So physical address we are talking about, actual address. Every computer will have a networking card that is called as the NIC, network interfacing card, or something like that, and that will have a very unique number, MAC address, which is the physical address, actual address, okay, which will be known or identified for source and destination. So data link layer making frames and then adding the MAC address, that is the actual physical addressing happens here. Then coming to the physical layer. Now actual bits and bytes will transfer from here. So the physical layer is responsible for encoding and decoding the data in the form of bits and defines the communication between two devices. It can be wired or wireless. So Ethernet, you can call the various network topology. All this is the work or is the responsibility of the physical layer. The physical layer will meet where? On the different machine, it will send the data. The different physical layer will accept that data, and then again this will go backwards. The other system will give these bits to data link layer. Data link layer will remove the trailer and header. The network layer above will try to find out the logical address, and the transport layer, the TCP, UDP, the ports, and actual application will be given the data. What is IP address? See, the IP address, first of all, IP address consists of a network address and host address. So IPv4, the IPv6 1998 has already come. So I'll tell you about IPv6 also somewhat. So IPv4, the 32-bit address is there, and host, and you can easily find out host and the network ID. There are class A, class B, class C subnet mask. So when you mask this like 255.255.0.0, therefore that is for class B. Now when you actually mask this with this IP address, you will get the network ID and the host ID. That is how this is a combination of, first you have to go to the network and then you have to find out the host, that is the computer, the network ID and host ID. That is 8.8.8.8. That is, I am talking about 8-bit, 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 8-bit. That makes a 32-bit. Now IPv6 is having 128-bit. It has 128-bit. So here the IPv4 I am talking about, it has a 32-bit internet address. This is used to define a host or you can say a router. So this is basically this is a logical address, but it logically is unique to the network. So the portion that identifies the network is the IP address, which is called as the net ID. The portion identifies the host or router on the network of the IP address is called as the host ID. So one part I am showing you, it is a network address. The other part I am showing you is the host ID. That is, first you have to go to the network, then you have to go to the system, computer or the computing device. And that can be done using the subnet mask, because we have class A, class B, class C, and we know the subnet mask also. Okay. So an IP address defines connection to a network of a device. So this two part is very important, network address and host address, and this IP address. See, IPv6 is already there. IPv4, because it's a logical system, this 192.168.1.1.2 is provided to you by the network administrator, but it is unique. because that IP will be for a whole network. Then you can also use subnet mask to divide it. Okay, so IP address or an internet protocol address is a series of number that identifies any device on a network. Okay, first part will take you to the network, the other part will take you to the host address. So computers use IP address to communicate with each other, both over the internet and as well as on the networks. So these are dot separated. Explain the three types of addresses in TCP IP. So there are three main types of addresses in TCP IP. The lower one, that is let's start with the top one. Now you are typing an email address, for example, in a browser. So www.google.com or any other. That is actually a process you are running. It is a process. You are using web browser, that is a process. Application, that is an application you can call. You are running a process, that is a specific address. Now that specific address will be linked to, because you are trying to communicate network using the computer network to another system. So we have this www.google.com, and that DNS system will convert into tell you the IP, and that will go to the transport layer. Now TCP will take this, and now you have a port number automatically generated by operating system. It will give you, and then you will give this IP of the system you want to connect. For example, you want to connect to web server along with port 80, because port 80 will be used for HTTP. You want to use the HTTP, or 443 you are going to use the HTTPS. So that will be an IP along with the port address. So here the port address will be generated. So right now the specific address was www.google.com, and port which you want to connect is port address. Now which IP you want to connect, that is your IP and that IP. This is the network layer. Here the IP address, a 32-bit IPv4 I am talking about, because IPv6 is 128-bit. So IP logical addresses will be formed in dot separated 32-bit, and then we have the physical address. We are talking about MAC address, that is data link and physical will give you the MAC address, physical layer. That is the medium access, the number which is very specific to a code, an IC card. So we have a physical address, the internet work address, and the port address. What is the function of a routing table? So just try to understand. There are number of computer, system, network devices on the network. Now, how to know which any system, how it will decide? Now packets has to be sent to which next hop, next say device. So there has to be some kind of organization. So the metric also to be known. You have two systems or two routers. Which router to be send the data? For that we make a table. Every networking device make a table, and that table is called the routing table. So this routing table is a set of rules. They are often viewed in table format, which you see here also. That is used to determine where data packets traveling over an IP network will be directed. Because there are number of options, but exactly where to send, that can be known only when you have a statistics, when you have a data with you, and that data statistics or a table is called the routing table. What is unicast, multicast, and broadcast communication? See, unicast is one-to-one, multicast is one-to-several, and broadcast is one-to-all. When one party is sending only to one single party, or communicating with single party, or sending the data or communication, this is unicast. When one party there are multiple systems here, it is sending to these two of them. It may be in the same network, it may be in the other network also. That is called the multicasting. Okay. Now, when a device, whichever device is connected to it, it sends or messages or communicates to all of them. That is called the broadcast. So multicasting is used when when there is a possibility of conferencing and information retrieval. What is process-to-process communication? See, let me tell you what are the processes. The processes are, whenever in your computer, when you open the operating system, whenever you open certain application like Microsoft Word or say some other, that is a service basically. That is a process. Now, when you open a web browser, because now you want to use the networking service. So those services, those applications will be called as processes. So web Chrome at your system will be process, and the web server running on some other system will be the process. So when you are going to Google Chrome trying to access a web page, you are going to use the HTTP hypertext transfer protocol, and this HTTP needs a port. So your port, and which port you want to access, because the processes are automatically generated by the operating system, your port, but there are the port 0 to 1023 which are fixed for services, for the processes. So HTTPS has 443 number of the number of port is 443. HTTP is 80. So now you have to communicate to that process web server that will have a port. You will ask for 80 because you want to, on the network, you want to travel or you want to do the web communication, networking you have to use. So for that, these are the processes. So the IP is considered as responsible for communication at the computer level, and as IP is a network layer protocol, it delivers the message only to the computer of destination. So IP is all about going to host. But this is incomplete delivery. The message needs to be handed to the correct process, because you may be working on 3 networking application. So which networking application this IP or the content has to be given? This is where a transport layer protocol like UDP or TCP takes over, and this is how they deliver to the actual process. For example, the web pages are coming, where it should go. It should be shown on your web browser, not to any other networking utility. For example, you are using FileZilla at the same time. So those web pages which are coming from the web server will not go to FileZilla, but it will go to your Chrome, and that is the process-to-process communication. So the process of communication refers to the transmission or passage of information or messages from the sender through a selected channel to the receiver, overcoming barriers that affects its space. The process of communication is a cyclic one, as it begins with the sender, ends with the sender in the form of the feedback. Explain buffering. See, buffering, when you have more money than what you can put in your wallet, what do? You put money, and then some money you put somewhere else. So just assume that you have an array. I'm just giving an example. Now, if a packet is coming, 111 portion it will take. What will happen to the 5th packet or 5th data segment? So the TCP creates sending and also receiving buffers for each and every connection, and these buffer will be advertised in advance when the 3-way handshaking will take place. That is, the connection will be established. So TCP always uses a buffer to store the stream of data coming from the sending application program, and the receiving TCP also buffers data when it arrives and also delivers the data to the application program. So you have, say, 2 hosts, both will have their own buffer, and since the connection TCP is full duplex, so the data is coming or going both the sides, and they will be kept in the buffer, and the buffer size is already advertised. So this also help in flow control, and if some of the segment is not there, missing, acknowledgement is missing, then there will be a retransmission. So here you see we have a buffer. Sending process will have a buffer. What is the next byte to write? What is next byte to send? What is not sent? And that not sent will take care of the reliability, because every kind of communication will be getting acknowledgement on both the sides. The things happening on the one TCP side, The same thing is happening on the other side. So you have a buffer where you keep things, what is being said, what is not being said means and what is sent but the acknowledgement is not received. And that is how the sliding window protocol works on this buffer. So this is the buffering. Okay. So let me tell you again. Let me clear it. TCP receive window is a buffer on each side of the TCP connection that temporarily holds the incoming data. The data in this buffer is sent to the application, clearing one room for incoming data. So one by one this is cleared and next data will be put here. So this is, you can just understand, for incoming data there has to be a temporary hold, and that is called the buffer. And if some packets are not coming, the acknowledgements are not coming, then there will be retransmission. That is why this buffer is kept. It also corresponds to the flow control. What is a router? What is function of router? And differentiate between a router, switch and hub. So let us understand about the router. So when we'll understand the difference, you will learn more. First thing is, router is a hardware device. It can also be a personal computer, PC or a computing device. So it is used to connect two or more IP networks. Now in this picture you see there is a sales department. It has its own LAN, local area network. The accounts department also has its own local area network, and these local area network are connected by a switch or a hub. Mainly we use switch, but the switch are intelligent hub. The second department also is connected using this hub or a switch. Now they are connected to a router, and router is connected to your internet. Okay, you got the idea what the router is doing? Actually, this word has come from route or route. That is the way, the path, the different hops. So a router is a device that connects two or more packet switch networks or the subnetworks, as you see here. So it has two primary functions. First is to manage the traffic between these networks by forwarding the data packets where it belongs, that is to their intended IP addresses. And second is to allow multiple devices to use the same internet connection. Now let us see one by one. Hub, switch and router. So you will know about the switch also and the differences also. The router also. Okay, first let me tell you ISO OSI layer. The layering scheme, it's a logical conceptual layer, and we have 7 layers of this ISO OSI layer, that is model scheme or protocol stack. We have APST and DP, application till physical. Now let us come to hub now. Hub works in half duplex mode. Now you see here I showed you the hub, that is switch works in a full duplex. Router also works in full duplex. What does it mean? When two parties are talking, they are talking together at the same time. That is full duplex. Half duplex means two parties are talking one at a time. When one is talking, the other will not be able to talk. That is hub. This is the first difference. Second difference. The hub sends the data in the form of bits. Hub is a physical layer device. It belongs to the layer 1. So it sends data in the form of bits. Switch, on the other hand, sends data in the form of frames. Router sends the data in the form of packets. It's a layer 3 device, network layer device. Okay, coming to broadcast device. Hub is just broadcasting everything. That is, if one client is there, all the information what it wants to send, it will send to all, whichever is connected to this hub. Okay, hub just transfers the thing. Switch does the multicasting. Multicasting, that is one device, if you have multiple, say the host connected, so it will send it to wherever it is intended multicastingly. The router is very specific. It routes, it is a routing device. So it will send the packet to the host for which it is actually intended. This is a routing device. Now fourth one is the layering. That is, hub works in the lowest layer physical layer. Router works where? Layer 3 device. So it works on network layer. Switch works in two layers. Layer 2, layer 3. That is data link also and network layer also. Right? Layer 2, layer 3, switch. Router, network layer, layer number 3. Hub, layer number 1. Then, hub is used to connect devices to the same network. That is a local area network which we see here. We want to connect the different hosts or the computing device, we use hub. The switch and router, they are used to connect devices to the network and used to connect two networks. Router is there to connect two different networks, as you see here in the picture. Switch, it is used to connect devices to the network. Why I'm not explaining more of it? Because it works both ways. Because it is a data link and network layer, both device. Okay. So just understand about hub. That is only same network. Router, two different network. Right? Two different network is important, which you see here. The sales department and account department, two different networks are there. The fourth one is hub does not store any MAC. MAC is a 48-bit specific address of, say, the NIC card on your system. So hub does not store any MAC address of a node in the network. But since switch also works on network layer, router also works on network layer, the MAC addresses and IP addresses of nodes will be stored. The hub can be, the types are active hub, passive hub, intelligent hub. The switch can be layer 2, layer 3 switch, and the router can be a broadband router, it can be wireless router, it can be edge router, it can be core router. What is a subnet mask? Now, subnet mask, this is used for two purposes. First is, this is used to differentiate between the network ID and the host ID. We will take the example of this. So we have 135.70.10 separated by dot. Now normally the networking guys, they put a slash and number. So for example, /8, /24, /32 like this. What does it mean? 16, etc. That means the number of bits which are 1. So 8 bits, that means the 8 bits are 1, others are 0. That just means like that. And then you can easily decipher or find out what are the bit sequence of an IP address. Now the subnet mask is used to differentiate, as I said, the network ID and the host ID of a given IP address. I'll show you how. The default subnet mask of each of the classes are already there. It is known: class A, class B, class C. Class A is 255.0.0.0. Similarly for B, C, 255 will be increased. There is one more task of subnet mask. The subnet mask, I'll just come to that. Let me explain the first part. Let us say we have an IP 135.70.1.0. Now, how to know the host ID and how to know the network ID? In order to know the network ID, what do? We use the subnet mask, and this is 135. As you know, this is a class B. This is class B. So what do? We just AND it with this class B subnet mask. So 255.255.0.0, which is the class B subnet mask, we just AND it. So AND what will happen? See, you will get, because 255, this is 1111, so you will get 135. Similarly 70, the 1 will become 0, the 0 will become also 0. So this part is your network ID. This is how you get network ID. Similarly, you can get the host ID. Okay. Now, the basic thing is that you have to go to the network, then only you can go to the host, that is the computer. That is how the subnet mask will help you. First, it will tell you this is the network, and then it will tell you this is the host. So network ID and host ID without subnet mask, very difficult. Okay, the second very important thing about subnet mask is dividing this network. A subnet mask is a way to divide an IP network. For example, you have an admin department, or say a stores department, or any other department you can say. We want to divide the admin and the store department differently. We want our main network to be divided into two parts. You can divide it into multiple parts like the area code of your phone number. So subnet masks are used in network to split them into 2 or more subnetworks, making them easier to manage. It is easier to manage admin and store department rather than having only one IP for that. So whenever the packet will come, see here, whole of the network is only known by 135.70.10. We are logically dividing it. So these are the 2 parts we are going to divide it. How to do this, I'll just tell you. But please remember, it is easy to manage these parts, or even you can go a bit further. You can also divide these parts again. So this IP will remain same, IP won't change. For the outside world, this whole network is having a single IP, which is 135.70.10 dot separated. So what we will do here is, these 2 parts we have to divide. So the first 3, the octet, you will never change. So what do you do? Because the last one is your host ID. So that is your network. That is your host network basically. So network is identified by the first 3 bit. So what you will do is, you will put 00000 8 times. You will fix this 0 for the first part, first subnet. That is the admin department. And for the store department, what you'll do, you'll keep the first 3 octets like that, 135.71. Now, wherever we have put 0 fixed, we'll fix 1 here, and then we'll not put all zeros. So only 2 parts. In this way, you can divide multiple times. So now, which IP belongs to which subnet? See, 135.70.1.0 is the starting IP of the admin department. 135.70.1. How much is this? If you this is binary. If you compute it in the decimal, it will be 128. So the admin department, the IP will start from 135.70.10 and it will end till what? 135.701 and 127. Similarly, the stores department will start from 135.70.128 and what will be there? 136.71 till 255. The first and last you cannot use. First is to identify your subnet, and the last one is for the broadcast. So this is, how many numbers are there? Just subtract 2. That is the usable IPs you can have. What is loopback address? Now we want to check our health. So in our computer system or in our operating system, if the TCP IP stack is there or ISO SI stack is there, whichever is there, whether it is working fine or not. For that, what we do? We use the loopback address. Loopback address. And we have different classes. One of the address is defined, is reserved for loopback address, which is 127.0.0.1. So the loopback address is 127.0.0.1. This is fixed. This address is used to check local TCP IP protocol suite or a local machine that your protocol stack is working fine or not. Okay? If you put it in the web address space, then you can have a client and you can have a web server on the same machine, because the same packet will be routed through this your TCP IP protocol suite and come back again to your server, because client and servers are the same machine. So a class A network number 127 is assigned the loopback function, that is a datagram sent by the higher level protocol to a network 127 address should loop back inside the host. Loop backing, it will never go. See, no datagram sent to the network 127 address should ever appear on any network anywhere. It will start from your machine and at your machine. From your application layer, it goes to physical layer, your physical layer, again come back to your application layer. So what do you type? Let me tell you, just ping your 127.0.0.1. You will get a reply that this is the bytes, this is time, and this is time to live 128. What is ping? What protocol is used by ping? So let us know the full form of ping first. It is Packet Internet network groper. Packet, internet, sometimes people call it as inter also. But let us go with packet, internet, network groper. Okay, now what does it mean actually? See, whenever you see your friend or anybody in your neighborhood, you say, hey there, how are you? The person will reply, yes, I'm good. So this is how normal conversation work. Same kind of conversation work in internet also, in network also, in intranet also. So if you want to just check the other system, you use ping. So ping uses ICMP, Internet Control Message Protocol. Sometimes people call it as management protocol also, but normally it is Internet Control Message Protocol. We'll go with Internet Control Message Protocol. So ping is network utility that refers to the signal sent out across this network to another computer, which then sends its own signal back. That is, you are sending it and it is just echoing back. This signal, which is measured in millisecond, lets you know how long it takes for a packet of data to travel from one computer or your host to a different host, or you can say to a server on the internet, and be back. So ping works by sending an Internet Control Message Protocol ICMP echo request. So it will be an echo request to a specified interface on the network, and then it will wait for a reply. So when you issue or type the ping command, a ping signal is sent to a specified address. When the target host receives the echo request, it responds by sending an echo reply packet. So let me tell you again, the ping is all about using ICMP, sending the echo request of ICMP, the target system, it will just send the reply of echo, that is echo reply packet. And this is what is ping. So let me just show you how does it work. Sometimes people say that only IP address can be used, but you can now use, because technology has advanced, you can just do ping google.com. It will tell you what is my IP, what is the time the packet will go and come, and the time to live also. How many packets are sent, how many received, what are the loss. The minimum and maximum time is also seen. You can know the average. 60 millisecond is the average time for the packet to go and come. So this is the ping. What is use of tracert? See, tracert is trace route. And we'll also see the difference between ping and trace route. Tracert. The source and destination. Tracert is to find path between source and destination. It shows number of hops, number of routers, number of points the packet has to go from source to destination. Tracert as ping, it is also using ICMP protocol, Internet Control Message Protocol. Okay, the ping is network groper. Okay, tracert is source and destination number of hops. So the trace route command, which is called as tracert, this is how we write, is a utility designed for displaying the time it takes for a packet of information to travel between a local computer and the destination IP address or domain. So traceroute command is used to determine the path between two connections. Often a connection to another device will have to go through multiple routers. The traceroute command will return the name or the IP address of all the routers in between these two devices. Now let us see what we actually do. Tracert, if you want to trace route of google.com, it will tell you that it has around 30 hops, and the hops, it says these are the IP addresses, this is the time being taken, and it gives you the whole idea that we have traced the route. So let us start with ping. Ping is a network utility that is used to test the connectivity between two nodes. ICMP protocol it uses, it will just send ICMP echo and the machine will reply with echo reply back. Okay, so basically ping is for knowing how much time it takes and also to know the health. This ping. So ping is, uh, as I said, you check the connectivity between the devices. The trace route is to track the pathway taken by a packet on a network from source to destination. Ping is used to test network connectivity and the name resolution also. Trace route helps us to find the exact path of the data packet to reach the destination, number of hops, number of routers. This is what trace route do. So the both can be used ping and just type IP address or just type the domain name. This all in trace route also you can do. You have seen this. The technology has got advanced. So just write ping with the domain name or just IP address. What are the well-known network protocols and their functions? See, there are plenty of protocols, but every layer which is being defined either in ISO OSI or TCP IP, every layer has certain protocol. And since we have network protocol, and the main thing is they use certain port. So I'll talk about port also. So UDP is connectionless, unreliable. TCP is connection oriented, reliable, and how these the different protocol work, we'll just give a hint about that. So let us start with the most popular one. The first one is, as I said, transmission control protocol. Please remember the TCP IP protocol stack is named after it. So you can understand the power and the usefulness of TCP. TCP is a popular communication protocol. It is a connection oriented, reliable protocol which is used for communicating over a network. So what it does is it first create a connection, that is three-way handshake with the party, that is the destination. Then it sends, there is a proper header 20 to 60 bytes, and there is a proper message, the error checking scheme which is called checksum. This is also there. Now coming to the internet protocol. As I said, TCP IP has TCP and IP. IP is working on the network. This is the protocol. And IP is designed explicitly as addressing protocol. So this IP is all about the logical addressing, IP address. It is mostly used with TCP. The IP addresses in packets help in routing them through different nodes or hops in a network until it reaches the destination system. So internet protocol or the network is all about the host to host delivery. User datagram protocol. As I said, TCP and UDP, they are the end-to-end delivery, that is process to process communication. The TCP is slow because it needs acknowledgement for every packet it sent. UDP doesn't want that. Use UDP just 8-byte header and the payload. So it does not form any kind of connection. It is connectionless and it is unreliable. But all audio and video is using UDP because the speed is very faster than TCP. See, online gaming, if you're using, you don't want any slack. So for that, you will use the UDP. UDP is user datagram protocol. Let me tell again, TCP is transmission control protocol. So UDP is a substitute communication protocol to transmission, especially for loss tolerating and low latency link between two parties, or you can say process or application. Now, post office protocol need to be known with the SMTP protocol, simple mail transfer protocol, because they are actually linked. See, SMTP is working on the application layer. So SMTP is designed to send and distribute outgoing mail from your system. When you send a mail, it will go to some mail server. So SMTP has a responsibility for that. Now, your machine, means the machine to which you have sent, it will pick up from the mail server. Who is going to pick up? POP3. POP3 is designed for receiving incoming emails. SMTP is designed to send and distributing outgoing email. So these both protocol work in tandem to send and receive email. Then we have the file transfer protocol, FTP. Now this FTP Most of the time you might be sending some files, multimedia files, text files, document, all these. So when you send a file, here comes the file transfer protocol. So this is transferring from one machine to another actual file. So since if you're sending 1 GB or say even 1 MB, 1 byte is missing, there is a problem. The file will not open. For that, you need a proper protocol, file transfer protocol, and you need a proper connection. For that, you use TCP. Now we have seen that SMTP we already seen work on 25 port. This is the port means the process port number. Now coming to HTTP. In your web browser, what do? You will use the web browser and try to access the web pages. So what is behind that? Which protocol will do that? Hypertext transfer protocol. So this is designed for transferring a hypertext among two or more systems. HTML tags are used for creating links. These links may be in any form like text and images. HTTP is designed on client-server principle, which is very important, which allow a client system for establishing a connection with the server, machine for making a request. It works on port number 80. If you are using HTTPS, it will work on port number 443. So the server will acknowledge the request as initiated by the client. Now coming to HTTPS. As I said, HTTP is not secure. HTTPS is secure. So you can call it as Hypertext Transfer Protocol Secure. So this is a standard protocol to secure the communication between two parties or two hosts, one using the browser, other fetching the data from the web server. So HTTP is used for transferring data between the client browser, which is a request, and the web server, which is a response in the hypertext format. Same in the case of HTTPS, which we just saw. S is for secure, except the transferring of data is done in the encrypted form, secured socket layer. So it can be said that HTTPS very difficult for it to be get hacked or sniffing or any other kind of wrong activity. Now telnet is for remote login. Telnet is a protocol for connecting one or more system and for remote login. Then coming to Gopher. Gopher is a collection of rules implemented for what? Searching, retrieving, also to displaying documents from isolated sites. So Gopher also works on the client server principle as HTTP and HTTPS. So these are the different protocols, very important protocols. What is keep alive? See, keep alive, this is a message which is sent from one device to check the connection health, whether the connection is still there or not. This is keep alive is just to check. For example, keep alive header when turned on helps the pages to load faster as browser and server do not have to make multiple connections and visiting multiple pages of website that can be done in a single connection. You don't want every web page should have multiple connection. You don't want that. So keep alive helps in that also. But basically keep alive is a message for checking the connection whether it is intact or not. So TCP keep alive timer feature provides a mechanism to identify the dead connections. When a TCP connection on a routing device is idle, not working for too long, the device sends a TCP alive packet to the destination party with only the acknowledgement flag turned on. TCP ACK turned on, just to keep the things alive or checking whether the connection is still there or not. So you send a packet and then you find out, okay, only the acknowledgement flag. There are 6 flags in TCP header. So ACK is only turned on. Typically this TCP keep alive are sent every 45 to 60 seconds. If the TCP connection is not working, that is you are not sending or receiving anything, it's a idle TCP connection and the connection is dropped after you get 3 sequential ACKs, they are missed. If the 3 sequential ACKs are missed, the connection will be dropped. This is how it works. And I was telling about the multiple connection of the web and web browser. This is what is the instance of that. What is a pure ACK? What is pure ACK? It is a TCP segment that contains no data, it is having only acknowledgement. This is known as a pure ACK. See, every TCP data communication needs an acknowledgement. So when sometimes you get the data along with the acknowledgement piggybacked. So TCP segment which does not contain any payload only has the ACK flag set 1 is called like that. So this is all about this discussion. Thank you so much. Take care of yourself.